Welcome everyone to Khadija Academy for electrical courses. Before we start this lesson, make sure to subscribe to our channel for more electrical lessons and hit the notification bell. Now let's go and start our lesson. Hi and welcome everyone. In this video we would like to have some solved examples on NEC 450.3, which is concerned with the selection of overcurrent protection or overcurrent protection devices for electrical transformers. So in the first example, we have an electrical transformer of an apparent power 45 kilovolt ampere. So this is the rated apparent power of the electrical transformer. It is a step-down transformer from 480 volt for the primary to 208 for the secondary. So it has 480 volt for the primary and 208 volt for the secondary. Three-phase transformer. Determine the maximum primary overcurrent protection setting if only primary protection is used. So in our electrical transformers or overcurrent protection, we have two classifications. Overcurrent protection device according to NEC standard. We have two tables, one concerned with a 1000 volt or less and another table for 1000 volt or higher. So simply less than 1000 volt use this table and over 1000 use this other table. So in our case here we have 480 volt to 208, which means less than 1000 volt. So let's look at the table that we are gonna use. So number one, we are gonna look for the full load ampere for the primary, which will be, so we know that S, which is our apparent power, divided by root 3 multiplied by V line to line, give us I phase. So here we have S, which is apparent power, will become 45 multiplied by 10 to the power 3, the rated power of the transformer, root 3 multiplied by V line to line voltage, 480 volt. By doing this, we will get the full load ampere of the transformer to be 54.127. So let's look at the table. This is the table from NEC, table 450.3b. This one is concerned with the transformers 1000 volt and less. 1000 volt and less, like in our case here. So it says that, hey, you have two conditions. One, if you are gonna use a primary protection only, so we have the transformer like this, we have primary, and we have the secondary transformer, either a single phase or a three phase, the same rules will apply. So let's say we have here a single phase transformer. So the primary we can protect only by using a fuse or a circuit breaker on the primary, or we can add an overcurrent protection on the primary and secondary. So dependent on the case, if you are gonna use only a primary protection, then you are gonna follow these rules in this row here. So we'll see that for primary protection, follow this part, and secondary not required. If you are gonna use a primary and secondary protection, then you are gonna follow these rules. Now in this example, we would like to see how can we apply if I need only a primary protection only. So number one, the full load ampere 54.127. So we have three columns here. We have current 9 ampere or more, less than 9 amperes, less than 2 amperes. This case here is 54.127 amperes. In this case, current of 9 amperes or more. Now we are gonna use a primary only, so we are gonna use this rule here. So we are gonna see 1.25 of this value. So the full load current or the overcurrent protection device rating 1.25, 125% of our rated current. So it will become 67.66 ampere for the circuit breaker or the fuse that we are gonna use. Now if you look at table 240.6a, which is concerned with the fuses and inverse time circuit breaker at less than 1000 volt, you will see that these are the standard ratings for these circuit breakers. So we will see that 67.66 is between here, 67.66 is between 60 and 70 amperes. So the question is, should I select the higher next one, the 70 amperes, or should I select the lower one, which is 60 amperes? So you can see the table says maximum rating. So by logic, you are gonna select the 60 amperes. However, there is an exception. If you look at here C note 1 for 125, it says that where 125% of this current does not correspond to a standard rating. So you can see 67 is not a standard one. It is between two values. A higher rating that doesn't exceed the next higher standard rating shall be permitted. What does this even mean? It means select the next one, which is 70 amperes. So in the end, we selected an overcurrent protection device for 70 amperes. Remember, this is an exception. It says maximum for whole table. However, note 1 for 125 is an exception to this rule. This one too is an exception to this rule. So let's have another example. A 75 kilovolt ampere, which is the rated power of the transformer, 480 volt to 120 volt secondary. This is the line-to-line voltage, and this is the phase voltage. Determine the primary and secondary overcurrent protection device. It means that we need to do both of our calculations. We need for primary and secondary. So let's start with the primary. Primary will be simply the rated power, which is 75 10 to the power 3 divided by root 3 multiplied by line-to-line voltage. So this will give us, as you can see here, 90.21 amperes. Now this rule doesn't matter if it is a star connection, or a delta connection. You are gonna use the same exact rule. Let me explain why. So we install the overcurrent protection devices here, like this. And for this delta, like this, we install it right here too. Now let's look at here. So what we need is that the full load ampere going through the circuit breaker here, right? So for a star connection, it will be, so star connection will be S divided by root 3 multiplied by V line to line. And we assume that this one is the line to line voltage. So in this case, it will be S over root 3 V line to line, which will give us this full load ampere current, which is the phase current. What about delta connection? So in delta connection, you will see that the V line to line is equal to V phase, right? Great. So if I would like I phase, it will be simply equal to S, the apparent power, divided by 3 multiplied by V phase, which in our case here will be the same as V line to line. This is the phase current. Now, what I need is that I need this current, which is I line. So in order to convert the I phase to I line, we need to multiply this by root 3. So root 3 divided by 3 will give us 1 over root 3. So you'll find that we have here S and we have here V line to line or V phase. So you can see exact same rule can be used for a delta and star in obtaining the full load amperes. In this case, it will give us the phase current, which is same as line to line. In this case, it will give us line current in which we install our overcurrent protection device. Okay, so let's look at the table here again for primary and secondary protection. Great. What is the current ampere? So this is a primary, greater than 9 amperes. So we are gonna use this value here, 250%. So we are gonna take 90.21 multiplied by 2.5 as an oversizing, like this, 225.53 amperes. Now if you look at our table, it will be between two values, 225.53. It will be between 250 and 225. Which one should I select? Now if you look carefully here, you will find that this is the maximum rating, like, okay, 250% C note 3. Note 3 talks about another thing, which is coordinated thermal overload protection. Forget about this. We are talking about the normal sizing without the presence of an overload protection or a thermal overload protection. Great. So in this case, we don't have this exception here. So since it says maximum, I have to go to the lower value, which is 225, as you can see here. So the selected overcurrent protection will be 225. What about the secondary protection? We need the secondary full load ampere. So it will be 75 divided by root 3 multiplied by 208, like this. So this is the secondary full load ampere, the full load ampere of the secondary of the transformer. It will be 208. Great. Now which rule I'm gonna use? Hey, it says determine the primary and secondary over current protection. So here this current is more than 9 amperes, right? And we are talking about primary and secondary. So we are gonna use this one here. So we are gonna take this and multiply it by 1.25, like this. So what you can see, it is between 250 and 300, between 250 and 300. We are 260.22 amperes. Which one should I select? Look at here. 1.25 has node number 1, which means if it is not corresponding to a standard rating, select the next higher one. Great, select the next higher one. So we are gonna select the 300 amperes, as you can see here. Great. Now remember, all of this is concerned with the protection of the transformer against short circuit. Most of them are short circuit, except these two, 1.25 and 1.2, can be used as an overload protection, but most of the others are short circuit protection. Okay, let's look at example number 3. This one for a transformer greater than 1000 volt, which has a different table. So we have a 5000 kilovolt ampere or a 5 megavolt ampere transformer with a primary of 34.5 kilovolt to 4.16 kilovolt secondary. The transformer has a rated impedance of 5.5%, and this is pretty important in the high voltage transformer, or to be more specific, medium to high voltage transformers. Determine the maximum primary and secondary circuit breaker if installed in any location. We have two types of locations in NEC, a supervised location and a normal location, which is non-supervised location. A supervised location, as we said before, is the location in which we have maintenance workers which are concerned with the monitoring of the transformer through all the time, to make it pretty simple for you. Anyway, let's look at the solution. So first, let's find the primary full load ampere. Again, the rated power, apparent power, divided by root 3 multiplied by line to line voltage. 34.5 kilovolt and 5000 kilovolt ampere. This will give us 83.67 amperes. So let's look at the table of greater than 1000. You can see here, maximum rating or setting of overcurrent protection for transformer over 1000. What does over 1000 mean? It means if primary greater than 1000, use this table here. The previous one, which is 450.3B, was concerned with less than 1000 volt. A concerned with greater than 1000 volt. Great. So here we have two classifications, that supervised, and this is the explanation of what does supervised mean, and any location, normal location, which is non-supervised location. That is the two specifications. We need any location. We don't care about supervised or non-supervised. So we are gonna use this one here. Number 2, what is the impedance of the transformer? Is it 6% or more than 6% and not more than 10%? So our transformer here is 5.5%, which means we are talking about this row here. not more than 6%. The second question, what type of the voltage of the primary and voltage of secondary? So the primary greater than 1000 volt, same as here. The secondary 4.16 kilovolt, which is greater than 1000. So we are gonna use this part here. So this is for the primary and this one for secondary. Now we have two columns here. We have circuit breaker and we have fuse. Circuit breaker and fuse. What type of protection you are using? Well, I'm using a circuit breaker for primary and secondary. Great. So we are using circuit breaker. So circuit breaker, it means I'm gonna use this one here. Circuit breaker, I'm gonna use this one here. So this one 600% for primary circuit breaker and 300% for primary of the secondary of this transformer. So what I'm gonna do is that I'm gonna take this value for primary multiplied by 600% or 6 times as seen from this table. So if you do this, you will have 502.04 amperes. Great. Now the question is, which one should I use? Okay, which one should I use? So let's look. But before I say this, we have to make sure of one important part. This table here is less than 1000. Okay, less than 1000. Great. Now greater than 1000, less than or equal 1000. Greater than 1000, we should look for the commercially available ratings. So the commercial availability may not be this great. So that more than 1000 has its own circuit breakers and fuses which are not found inside the NEC standard. You can find them commercially. So you'll see that here the next higher commercially available for above 1000. Less than 1000, use the standard rating. So this one for less than 1000, 1000 and less. And next highly commercial is for 1000, above 1000, meaning that I have to look for commercially available circuit breakers or fuses and see which one is close to my value here. Now what I need, let's say for simplicity, that these are the available commercially available circuit breakers and fuses for simplicity. Okay, so in our case here we have 500 and 600. So we have 500 and we have 600, and this one is 502.04 amperes. Now which one should I select? According to NEC standard, for 600% C note 1. So it says that where the required fuse does not correspond to a standard rating, a higher rating or setting shall be permitted. It means if I am following the NEC standard strictly, I have to go to the next level. It means I should select this 600 amperes. But from an engineering perspective, you will see that this is 502 and this one is 500. I will say, hey, I'm gonna select the 500. It is close to it, not very far, so I'm gonna select this one. So if you are following the NEC strictly, use the 600. If you are saying that, and this is pretty important, which one can help me also decide if 500 is sufficient or not? Remember, all of these oversized values, 600%, 300%, 400% and more, all of this is because of the inrush current of the transformer. That's why we oversize my circuit breaker and fuse, because I don't want my breaker to trip. That's why the size is 600%. Now if I selected the 500 ampere and the transformer didn't trip, then I can use the 500 instead of the 600 amperes. If the transformer trips, then I have to select this 600 amperes. Now what about the secondary? Secondary, again, rated power divided by root 3 multiplied by line to line voltage, which is 693.93 amperes. So if I look at this value here, and we have 300% over 1000 for secondary, then I multiply this by 3 like this. So it will give us 2081.79, which is between 2500 and 2000. Which one should I select? Let's look at here. 300% has node number 1, which means again we have to select the next level, which means 2500, because this is according to the exception in the NEC. Now, for example, if you look at here at supervised location, for example, at this one, this 600% does not have node 1 under it. So it means that if I have supervised not more than 6% and 600%, then I have to go to the lower value. So for example, in this case, I will have to use the 500 amperes. Because we don't have the exception here. Node 1 does not exist here. Node 1 or the next level only for these breakers only. Anyone has node 1. Any other setting that does not have this one, we will select the lower or the lower level. Okay, I hope this lesson helped you understand everything regarding the sizing over current protection in transformers.